Algebra 2 students. In this video today we will be looking at three different types of variation, okay? Three different types of variation. Of course, later I will explain what I mean by variation, but we're going to be looking at direct variation, inverse variation, and joint variation, okay? So here we go. Obviously, you know what your heading is going to be. It's going to be direct, inverse, and joint variation. Lessons 2.4 and 10.2, and I'll talk about that in just a second, okay? Direct, inverse, and joint variation. Be sure and include today's date, alright? Be sure and include today's date so that your notes are organized. Now, you don't have to do this, but if you want to, you can. But if you were to go back and look at your notes from lesson 2.4, you will see that we did not cover direct variation. I skipped direct variation on purpose because I wanted to cover these three topics at one time. To be honest with you, they are usually covered together. Okay, I'm not sure why the book split them up. Now, I don't remember if I told you guys we were going to do this when we were back on lesson 2.4 or not, but either way, that's what's going on here, okay? So having said that, let's start off by looking first today at direct variation. Direct variation. Now, this can be a little confusing, but if you'll take good notes, pay attention, I think you'll be just fine. Copy this down in your notes, please. Direct variation exists between two variables when they have the following relationship. Direct variation exists between two variables when they have the following relationship, and here's the relationship. Y equals kx. K is a constant. This, my young math scholars, is the model. Okay? This is the model for what? Direct variation. Got it? This is the model you will want to memorize. When I use the words direct variation, you think of this model right here. Now, K is a constant. That means that K is a number. So let me quickly off to the side here write down some examples of direct variation. Y equals 2x. That's direct variation. By the way, this K right here is called your constant of variation. You do need to know that. Your K is called your constant of variation. Constant of variation. That's what K is called. Okay, in fact, that's what K is called in all three different forms of variation, okay? So I probably won't mention that again. K is called your constant of variation. So in this model right here, y equals 2x, what is your constant of variation? Well, it's 2. Here's your y, here's your y, here's your 2, here's your k, here's your x, here's your x. So in this model right here, k equals 2. So 2 is your constant of variation. So let's write a bunch of these. This is direct variation. Sure it is. This is direct variation. This would not be direct variation. Boom. As soon as you put plus or minus, it's no good. Direct variation is simply y equals kx. That's it. In case a number. Now, so really the relationship means this. Whatever x is, you multiply it by a number and you get k. In this case, the number would be, let me erase these. In this case here, the number would be 2. So what does that tell you about y? That means if you put 2 in for x, if you put 2 in for x, 2 times 2 is 4, you would get 4 out for y. So in other words, all of your y values will be twice as big as your x values, because every x value you put in, every x value you put in is being multiplied by 2. So, this is direct variation. When you have x being multiplied by the same number, giving you out your y value, we call this direct variation. Okay? Alright, now, we would say in this instance, here's the phrase you need to get used to. Y varies directly with x. That when you hear y varies directly with x, you think of this right here. swap places. Now that's probably not going to happen. Okay, don't worry about that, but I'm just saying, understand what this phrase means. Y varies directly with x means y equals kx. X varies directly with y means x equals ky. But we're not going to get to that for now, so that's fine. Y varies directly with x means y equals kx. You need to know that. Now let's take notice of some things about this model. It's really important. Are you ready? Let's take some really good notes here. First, it's linear. Come on, guys, it's common sense. Y equals 3x. That is a direct variation equation. Y varies directly with x. Here's my y, here's my x, here's my k. This is a linear equation, you know that. If I were to graph this, I'd get a straight line, wouldn't I? If you put 0 in for x, you get out 0, 0, 0. Put 1 in for x, and you get out 3. So 1, 3. Put in 2 for x, and you would get out 6. For y, 2, 6. There we go. A linear graph, okay? So the first thing you need to understand is that a direct variation equation is linear. It is linear. Now moving on. Second, it'll always pass through the origin when graphed. Always. Copy that down. Think about it, guys. Here's the graph we just had, okay? Right here. This is the graph I just had up there. Look, guys. If you put 0 in for x, what are you going to get out for y? 3 times 0 is 0. 0, 0. I don't care what direct variation equation you put up here. You can put y equals 5 million x. It doesn't matter. If you put 0 in for x, 5 million times 0 is 0. So y would equal 0. So for a direct variation equation, every time you put in x, you're going to get out y. So this ordered pair right here always exists in a direct variation equation. Thus, the graph of a direct variation equation will always pass through the origin. Alright, moving on. Lastly, k is the slope of the linear graph. Okay, that's the last thing. So, does that make sense, guys? If I have y equals 2x, let me ask you a question. Let me ask you two questions. Is y all by itself? Yes, it is. Well, I have taught you at the beginning of the year, in a linear equation, when y is by itself, the number next to x is always your slope. Remember, y equals mx plus b. You say, well, there's no b. Yeah, there is. Plus 0. Sure there is. So I'm just pointing out to you k in a direct variation equation. Let's stop. Let's stop right there. I'm not saying k is always the slope. Remember, we're going to look at inverse variation. Got it? And we're going to look at joint variation. Got it? Okay. Right now I'm talking about direct variation. In a direct variation equation, k is also the slope. Okay? Alright, moving on. Now let's practice writing some equations that give y varying directly with x. Y varying directly with x. Let's write some equations. How do we do that? Well, it's really easy. Here we go. Please copy this down. Take some really good notes. If I said, write an equation that gives y varying directly with x, and I said x is 5 and y is 12, here's what you would do. Are you ready? Take some good notes. We're going to write equations that have direct variation. So what's the model you're going to write down right away? Got it. That's step 1. Now let this sink in, guys. Pay attention. If I have direct variation, then this is the model that I write down. Well, k is a number, isn't it? So all I have to do is find k, and then I can write my equation. How would I find k? Well, here's x, 5. Here's y, 12. Isn't that easy? Where the x is, I put what? 5. Where the k is, I put what? 12. Now divide both sides by 5, because you're solving for k. I mean, k times 5 is the same thing as 5k. So let's divide both sides by 5. And when you do that, you're going to get 2.4. So we can call k 2.4, or if you want to, I don't care if you call it 2 2/5, or you can call it 12 over 5, any of those numbers. And there's your equation. Y equals 2.4x. So y equals 2.4x shows direct variation between what two numbers? 12 and 5. 12 and 5. Y equals 2.4x shows direct variation between 12 and 5. Let's try another one. You can work out or watch me. I want you to write a direct variation equation, or in other words, an equation that shows y varying directly with x. So as soon as you hear the word directly and varying, you know you want this model right here. Okay, there's your model. Now you want to solve for k. You have to find k. So for the y, I'm going to substitute 22. For the x, I'm going to substitute negative 3. Now divide both sides by negative 3 and you will get negative 22 over 3. Or if you want to put negative 7 and 1/3. Or if you want to put negative 7.3 repeating. Any of those are fine. I'm going to use this one for no certain reason. I just feel like it, so that's what I'm going to use for k. So now that I know what k is, I come up here and where k is right here, I put negative 22 over 3. So my answer is y equals negative 22 over 3x. And I did it. I just wrote an equation that shows direct variation between 22 and negative 3. Right here. There's your answer. This is really easy stuff, guys. You simply notice what variation we're dealing with. Direct. So you write your direct variation model like this, and then solve for k. And then once you solve for k, that's not your final answer, but you simply pick up k and put it right here, and then you're done. That's the answer. Not too bad, guys. Let's try another one. Now I'm going to take it a little further, okay? Here's what I want you to do. Write down some really good notes here and listen. I want you to write an equation that gives y varying directly with x, but then once you do that, after you've done this is a two-step problem, okay? After you've done that, I then want you to find y when x equals negative 4. So for right now, if you would please, forget this. Don't even worry about that right now. This is a two-step problem. The first thing I want you to do is I want you to write an equation that gives y varying directly with x. So I hear the words equation varying how directly, so I write my model. There's my model for direct variation. Here's y, so I'll put a 10 for y. Here's 2, I'll put a 2 for x. Divide both sides by 2, and what does k equal? 5, so pick up your 5 and put it right here for k. So there's part 1 done. It's a two-step problem. There's the first part done. Now, what they want you to do is they want you to find y when x is negative 4. Find y when x is negative 4, no problem. So, I'm going to find y when x is negative 4, so I come over here for x. And for x I put what? Negative 4, because that's what x equals. And so what does y equal? Negative 20. So it's a two-step problem, or a two-part problem. First, write the direct variation equation. I did that. Then once you've written the equation, find y when x equals negative 4. So where the x is, you put a negative 4. Okay? Just that simple, guys. It's not difficult. Pretty simple. Please make sure that you know how to write an equation that relates x and y. How? Directly. What's the model for directly? Y equals kx. Alright, moving on. Let's move on now to inverse variation. Copy this down, please, in your notes. Inverse variation exists between two variables when they have the following relationship. Inverse variation exists between two variables when they have the following relationship. saying. That's what you have to do. You have to know the two different models. We're going to learn a third model here in a second. Of course, we're looking at three different types of variation. You have to know all three models to solve these problems successfully. Alright, so here's the relationship. Now here's what it really means. Okay, watch this. Inverse variation exists between two variables when they have the following relationship. Y equals k over x, where k is a constant. Whatever you're putting in for x always goes under k. Alright? So I mean, that's pretty, I'm kind of joking, it's pretty profound. I mean, I know it's pretty obvious, but look, that's all that this is saying here. Whatever you're putting in for x, whatever your constant k is, will just go above x in a fraction form. So if I have y equals 3 over x, right here, I wrote this down a second ago when the video was paused. If I have y equals 3 over x, if I put 1 in for x, I get out 3. If I put 2 in for x, I get out 3 halves. If I put 3 in for x, 3 over 3 is 1. So whatever I put in for x, 3 just goes on top of it for my y value, okay? And so maybe you understand that, maybe you don't, but the main thing you do need to know is this. When you hear the words inverse variation, think of this model here. You have to, okay? It's very important. Now, we would say in this instant, y varies inversely with x. Y varies inversely with x. If it says y varies directly with x, then you would think of this. Do you see the difference? One is multiplying, one's dividing. Y varies inversely with x, think of this. Y varies directly with x, think of this. Pretty simple. Here are some things about this model, inverse variation. Notice it's a rational expression. It is, Mr. Earhart, sure it is. Let's say we have y equals 5 over x. That is an inverse variation equation. Here's my y, here's my x, and here's my k right here. 5 is my k, alright? So I have a direct variation equation. Well, guys, look at this. How do I know it's rational? We just learned this in lesson 10.1. Is this a polynomial right here? Sure, it's a polynomial. It's 5x to the 0 power. Is this a polynomial down here? Sure it is. X to the 1 power. So if I have a polynomial over a polynomial, we just learned from lesson 10.1 that is a rational expression. So a direct, excuse me for saying direct, an inverse variation equation, an inverse variation equation is a rational expression, just like a direct variation equation is linear. Okay, we covered that earlier. A inverse variation equation is a rational expression. Okay, so we'll keep this in mind right here. Now, that means the vertical and horizontal asymptote will always be at 0. And guys, that's obvious. Come on, we learned this the other day. How do you find the vertical asymptote? You take the denominator, set it equal to 0, and solve. So x equals 0. There's your vertical asymptote. It's always going to be 0. Look at your degree. Your degree up top is a 0. 5x to the 0 power. Your degree in the bottom is 1. So your degree up top is smaller than the bottom. So we have a horizontal asymptote at 0. It'll be that way for every inverse variation equation. So for inverse variation equations, we have vertical and horizontal asymptotes at 0. It is a rational expression. Now let's practice writing some equations that give what? Y varying inversely with x. Let's practice writing some equations that give y varying inversely with x. Got it? So here we go. I'm looking at writing an inverse variation equation. As soon as you hear the word equation and vary inversely, you should think of this model right here. There it is. Got it? So let's write the equation. First of all, we have to solve for k like always. So here's my y, I'm going to put a 12. Here's my x, 5, so I'm going to put a 5 for x. Now, this is so simple. How would I solve for k? Well, the 5 and the k are not multiplying, they're dividing. What's the opposite of divide? Multiply. So I'm going to multiply both sides by 5. Multiply this side by 5. Multiply this side by 5. 5 times 12 is 60. Over here, k over 5 times 5 over 1. Your 5's cancel, leaving you with k. So in other words, whatever the denominator is, you multiply both sides by that number. So there's k, I found it. Now I'm not finished. I'm writing an equation. So here's k right here. I'm going to pick up 60 and put it for k. And there's my answer. Remember, k is called your constant of variation. So we found our constant of variation at 60, and there's my inverse variation equation. This equation right here has y and x varying inversely. Alright, this is your inverse variation equation. Let's try another example. I want you to write an equation that gives y varying inversely with x. So as soon as you see that, we're going to think of this model here. There it is, okay? Now, in order to write an equation that has y varying inversely, I've got to solve for k. So where the y is, I'm going to put 22. Where the x is, I'm going to put negative 3. Because here's my x and here's my y. Now your denominator is negative 3. So multiply both sides by negative 3. 22 times negative 3 is negative 66. K over negative 3 times negative 3 would cancel out your negative 3's, leaving you with k. So there, I solved for k. I multiplied both sides by my denominator, which is negative 3. So there's my k. Now that I know what k is, I can quickly write my equation by picking up 66, negative 66, and putting it right here for k. So y equals negative 66 over x. And look at that, there we go. And don't forget, that is a inverse variation equation. Thus it is a rational expression. Thus this equation has vertical and horizontal asymptotes at 0. Okay? Alright, moving on. Let's try another one. Now this is a two-step problem. First we're going to find the inverse variation equation, and then after we do that, we're then going to find y when x equals negative 4. So let's totally ignore this right now. Let's do the first part first. Let's write the equation that gives y varying inversely with x. First, so I see equation vary inversely, so I think of this model right away. Now where y is, I'm going to put 10. Where x is, I'm going to put 2. Now what is my denominator? 2. So multiply both sides by 2. 10 times 2 is 20. K over 2 times 2, your 2's would cancel, leaving you with k. So now I know what k equals. So up here where k is, I'm going to put 20. Y equals 20 over x. There's your answer for part 1. Now part 2 says to do this. Part 2 says to find y when x is negative 4. So find y when x is negative 4. So where the x is, I'm going to put negative 4. Obviously y equals negative 5 because a positive divided by a negative is negative, and 20 divided by 4 is 5. So there's the two answers. Part 1 answer, or step 1 answer, y equals 20 over x. That's your direct variation. That's your inverse variation equation. And then when I put negative 4 into the equation, I get out negative 5, so y equals negative 5. Okay? Alright, I hope this is making sense. Now, please make sure that you know how to write an equation that relates x and y inversely. We just did that. Please make sure you know how to do that. So far you should be able to write direct variation equations and inverse variation equations, okay? You should be able to do both of those. Direct variation, you think of this model right here. Inverse variation, you think of this model right here. product of two or more variables. Copy all this down. Okay, I'll explain in a second. For example, if I say V series, if I say Z varies jointly with the product of X and Y, then I would write the model like this. I'll put it down in a second. Just copy this down, please. Joint variation exists when a variable varies directly as the product of two or more variables. For example, if I say Z varies jointly with the product of X and Y, I'll write the model like this. Z varies jointly with the product of X and Y. So it's really like direct variation. Y equals kx, except now the k has two variables with it, X and Y. So Z varies jointly. Jointly usually means together. Okay? That's what the word jointly means, together. So Z varies together. It varies together with what two things? X and Y. And what about the X and Y? What are they doing? Product, so they're multiplying. So Z varies together with the product of X and Y. Z varies jointly, here's your K, with X and Y, the product of X and Y. So the model would look like that. Z equals KXY, and K is a constant. Okay, so this would be an example of Z varying jointly with the product of X and Y. There. That's an example of Z varying jointly with the product of X and Y. What is your K? Your K is -5. Your constant of variation is -5. Got it? So, before I put anything else up here, let's go over this again. If I say direct variation, what do you think of? That. If I say inverse variation, what do you think of? That. If I say joint variation, you think of this. Alright, there we go. Now let's practice writing some equations that give Z varying jointly with the product of X and Y. So in the past we did direct variation equations, and then we did inverse variation equations. Now we're going to do jointly variation equations. Okay, so here we go. I want you to write an equation that has Z varying jointly with X and Y. So Z varies jointly with X and Y. Okay, here we go. First of all, if we're going to write the equation, we have to solve for K, do we not? Sure we do. So for Z, I'm going to substitute 2. For K, I'm going to put K. For X, I'm going to put a 5. For Y, I'm going to put a 12. Now let's simplify this side over here. 5 times 12 is 60, so I have 60K. Now divide both sides by 60 and you get 1/30. For K, if you want to put a decimal, 1/30 is 0.033333. That's up to you. I'm going to leave my K like this. So now that I know what K is, I'm going to pick up this right here and put it in for K right here. So Z equals 1/30 XY. And that is your equation that gives Z varying jointly with X and Y. Let's try another one. I want you to write an equation that gives Z varying jointly with the product of X and Y. So, as soon as you see the words equation and Z varies jointly with X and Y, you're thinking Z varies jointly with X and Y. Where the X is, I'll put -3. Where the Y is, I'll put 22. And where the Z is, I'll put 0.75. And here we go. Let's simplify this side over here. 0.75 equals -3 times 22 is -66K. Now divide both sides by, and I'm wondering if I made a mistake on the last problem, did I? I hope I did not. I'm just having those doubts for a second. No, everything looks good, okay. So now divide both sides by -66. So 0.75 divided by -66 equals a really weird number. -0.75 0.0114 if you round. Okay, that approximately equals k. So now that I know what k equals, I'm going to pick this up and put it in for k right here. So my equation would be c equals negative 0.0114xy. And there is your joint variation equation. Alright, we're just about done. Hang in there, okay? Now, let's do one more of these, but it's going to be a two-part problem, okay? So let's focus on the first part first. The first part is write a joint variation equation. So as soon as you hear equation, C jointly with x and y, you think of this. C varies jointly with x and y. Here's C, so I'll put a 4 right here. Bring down my k. Here's x, I'll put 2. Here's y, so I'll put 10. So 4 equals 20k. 2 times 10 is 20. Divide both sides by 20 and you will get 1/5 equals k, or you can use 0.2. I'm going to use 0.2 for no certain reason. Okay, this is what I'm going to do. So here's what k, I'm not sure why I put a 4 there. So 0.2 equals k. Now, I'm going to pick up 0.2 and put it in for k right here. So my equation is z equals 0.2xy. Now, that is my joint variation equation. So I did part 1, I wrote my equation that has c varying jointly with x and y. Now to the second part. I want you to find c when x and y have these values here. So we're looking for c 0.2 times when x is negative 4 and y is 5. Okay? So all that we're simply doing is we're multiplying three numbers together. Pretty simple. We're just taking 0.2 times negative 4 times 5. And if you type that into your calculator correctly, you will get a negative 4. A negative 4. So there's the answer to the second part of the problem. Okay? And that's it, guys. These are not that difficult, really, as long as you understand direct variation. Think of this. Inverse variation. Think of this. And joint variation. Think of this. Alright? And that's it. Please make sure that you know how to write an equation that relates z varying jointly with the product of x and y. I hope this video has been a help. If you have any questions,